that we also think is really interesting. We think it's super difficult. So as the algae evangelist, I'm looking forward to your explanation. But I think also it's a very, very important area for how algae can help with the sustainability issues of the world. So welcome, David.
Thank you very much, Eric. Morning, everyone. I trust you all had a good night's rest. When I presented this, before, I didn't really make as much of a connection with the idea of carbon capture in soils. But for this conference, because I saw what the session heading was, I said, let me really focus in on that issue and try to present soil algae in the context of carbon capture, not just what they are good for in the soil. But I call them the unknown, unsung heroes of life on terra firma. A lot of people don't realize the role that they play on land. You think algae, you think aquatic species. So we'll go into some details of the aspects that you see here, why is soil important, and why soil algae are perhaps the least known of the microbes that exist on the planet. But how important they are in so many different ways to life on land. So what do they have to do with carbon capture and carbon storage? Essentially, the world's soils represent a massive carbon sink. And we've been losing carbon from soils through the practice of agriculture for about 12,000 years. And this is just some of the data that's out there. We've lost a total of 133 billion tons of carbon since we first started farming the land. And then we started to change things with the invention of the Haber-Bosch process, by which we were able to create synthetic nitrogen from natural gas. And those fertilizers have been in use for quite a long time. And now recent research is showing that while it may have seemed like a good idea at the time, it's having a lot of deleterious effects on the soil itself and on our ability to produce food for the estimated 9.5 to 10 billion people that we have to feed by 2050. But the soil is extremely important. There are so many things that revolve around soil. It's at the nexus of air quality, water quality, food production, human health. It's just as important a natural resource as air and water, but we often don't think about it. And one of the things I say to people is, please don't treat your soil like dirt. So this is probably, you're just going to have to watch and see what, we don't have the audio, unfortunately. Maybe it doesn't make sense, I'll just skip over the video. But talk about the organic inputs to soil and the fact that soil comprises living and non-living elements. If you don't have the living organisms in soil, you have dirt. It's that simple. Soil is healthy soil. A tablespoon of healthy soil will have more living organisms in it than there are people on the planet. That's 1 gram of soil they're talking about. 25,000 earthworms per hectare. you're going to keep adding more, and get less. So agroecology or regenerative agriculture. So I think you got the gist of it just by looking at the graphics. But essentially, if it's in your soil, it's likely to be in the plants that you grow in that soil. And if it's not in the soil, it's probably not going to be in the plants that you grow in the soil. If you make those connections, you'll understand why it's not such a good idea to pour so many chemicals onto your soil. And if you destroy the soil's ability to provide the nutrients that the plants need, then the plants won't produce fruit or the crop that you want with the nutrients that we need. So I've interspersed into this presentation a few of the testimonials that we've seen from folks who've used algae in soil. And this is coming from Colorado, and they say that they treated soil with algae. When they got back their soil test results, it needed nothing. And everything else needed at least 100 pounds of nitrogen. What makes soil healthy? So we've established the importance of soils, but what is important to soil health? And I've hinted at it. It's the living component of soils that make soils healthy. Nutrients, organic matter, carbon, minerals, microbes. And among those microbes, algae. But we don't know a whole lot about algae's contribution to terrestrial systems. There's very little study that has been done. We've not focused on them to a large extent. These are my suppositions on why not. Humans are enthralled by big things. The bigger they are, the more likely we are to pay attention to them. We live in a macro-oriented world. We only look at microorganisms if they're likely to make us sick or kill us. Then we study the heck out of them. Okay? That's our pattern. We do study some beneficial microbes for things that are of economic importance to us. And maybe that's where we need to go with algae, because they can be of economic importance to us, directly and indirectly through their impacts on soils. But microalgae, the least study of the beneficial microbes. And among microalgae, we probably know more about those that cause toxic effects, as in harmful algal blooms, than we do those that are beneficial. When we study microalgae, we study the aquatic species. Very little research is done on the terrestrial species. And believe me, algae occur everywhere. They're in deserts, they're in the Arctic tundra. You name it, you'll find algae there. As a matter of fact, they're very important in soil formation to begin with. But they are among the least studied of algae, and algae are the least studied of microbes, and so on. Why have we really paid attention to them? They're difficult to study to begin with. The ecological parameters in soil are very difficult to evaluate. If you understand that soil is laid down over time in layers, imagine, if you will, 10 centimeters of soil. The organisms that are adapted to live 10 centimeters depth would not know what to do on the surface. the climate, the microclimates in soil differ so radically as you change in depth that you can have totally different habitats in the same soil. And the organisms that are adapted to live at depth can't live on the surface, those on the surface can't live at depth. What do you think happens when we plow or till? We disrupt that. And over time, it destroys the microbial life in soil. So the plow is another invention that I think was one of those, it seemed like a good idea at the time. Because if you look at what happens in soil with the microbial activity, they do everything that we think plowing the soil does. Because of this, there's high uncertainty in identifying species. It's difficult to observe where they live. And when you enrich a culture from a soil sample, it tends to favor the weed species, not the specialists. So you get a skewed idea of what's there. Here's another testimonial. This is from one of our partners in Colorado who's been using Activate for several years now. And this is saying he got an increase of 15 to 20% on his corn yield and a 5% increase in test weight. He went from 57 pounds to 59 pounds per bushel of corn. If you look at, let's say you Google soil ecosystem or soil food web, and this is what usually comes up as one of the top searches. The soil food web, with the first trophic level being photosynthesizers, and then you have the other trophic levels going up to the apex. But these recognize the photosynthesizers as being those that are above ground and producing, through their root systems, material that the microbes need. Yes, we know a lot about that, and we know that plants provide food through their root systems to attract microbes to their roots. They know the beneficial effects of having microbes around there. But very, very few people understand that algae, photosynthetic algae, live in the soil, and they produce the primary production in soil ecosystems. So it's not just the plants with the roots extruding into the soil, but there are algae in soils, in healthy soils. They produce oxygen, they produce on their cell walls substances that are of extreme value to soil structure and function, and also as a food source to the other microbes. Here's another image of what we expect to see in a soil sample or soil ecosystem. And again, you don't see, you see very little mention of algae. So what do they do in soil fertility? How important are they? They're the base of the food web, not just in soils, but in every ecosystem in which they occur. They are part of the primary producers. They're the primary producers of the planet, really. And they provide food to the other the non-photosynthetic organisms in soils. When you don't have that layer in soils, you have to keep adding food for the other microbes. It makes more sense to have a natural supply, unending supply. They secrete substances that protect the associated plants. Algae as living organisms produce substances that protect themselves from diseases and other types of predation. You have a healthy culture of algae in soils, that defense mechanism also protects plant roots. When you have a healthy plant root system, you have healthy plants. There are algae, or cyanobacteria, that convert atmospheric nitrogen into nitrogen in a form that the plants can take up. No plant can use gaseous nitrogen. They have to absorb it in a different form. And even when you do like rotation of crops and you put legumes on your soil, and your soil becomes enriched with nitrogen as a result, it's not the plants themselves doing it. Cyanobacteria associated with the root systems of those plants that do the nitrogen fixation. They act as a cementing agent. So if you have algae in your soil, it holds the soil better, and that material is also hygroscopic in nature. It holds water for longer. And if there are any nutrients in the water, it will also hold those nutrients in for longer. They add organic matter to the soil when they die. It's natural. Their secondary metabolites help to mineralize those minerals that are bound in the soil. So phosphates can be released from the soil for plant use. They liberate oxygen in the soil, and they reduce the loss of nitrates as a result of holding the water in the soil longer. They weather rocks. So together with fungi, in a form that we know as lichen, there's a symbiotic relationship between algae and a fungus that is the first to colonize bare rock and bare soil. And it's a natural understanding that they both came out of the water. The fungi could find and hold water, but it couldn't photosynthesize. It couldn't produce its own sugars. Algae could do that, but it couldn't find and hold water. Started working together. And that's the formation of the lichen symbiosis. And they produce phytohormones that aid in plant growth and regulate plant growth. Auxins and gibberellins and all that good stuff. According to Maestre et al., algae and cyanobacteria cover the top layer of the soil surface in most arid and semi-arid ecosystems throughout the globe. They help to secure the soil from erosion, and they help to break down the bare rocks and bare soils. Here's another testimonial. The guy says he used 6 ounces of an algae soil amendment, and he's never seen the production of it out of his vegetable garden. And we've been getting that sort of response from everybody who's tried it. These are some SEMs, scanning electron micrographs, of the function of cyanobacterial sheets holding soil particles together. On your left, you have the landscape with healthy soil crusts, again, algae, cyanobacteria, and you get a good look at another cyanobacterial sheet holding sand grains together. If you've never been through a dust storm, you will never understand the importance of this. But we lose a tremendous amount of soil as a result of wind effects. I won't go through all of these, but suffice it to say that you look at almost every crust type, and it's all algae. Algae, cyanobacteria, algae together with fungi. This is an example of showing how the lithocere on a raised beach is weathered. First things that come in, blue-green bacteria, aka cyanobacteria. And then you have the lichens, which are fungi-algae associations. They make it possible. They break down the rock. It takes about 2,000 years to create 10 centimeters of soil. Normal processes. It's a lot faster when you have biogenic processes at work. So wind and rain and the freezing and thawing and so on. Yes, it breaks rocks up, but it will never do it as quickly as the biological effect. Another testimonial, side-by-side trials. So there are pictures that you will see, one bed of broccoli, one bed of broccoli, one treated with algae, one without. Differences are remarkable. But let's look at algae versus synthetic fertilizers. And I'll give credit where credit is due. I requested and got permission from Dr. Stephen Gomez to reproduce the next 6 slides, I think, from one of his presentations. This is the fate of synthetic fertilizers in soil. It's only about 50% efficient. 50% goes to the plants, the other 50%, 25% is either leached or denitrified, or goes to feed the organisms in soil. So you put on 100 pounds of synthetic fertilizer, only 50 pounds of that actually does any work. And when you stimulate the soil organisms through synthetic fertilizer, it starts doing some really bad things. They actually release nitrous oxide, which is about 100 times more potent as a greenhouse gas than carbon dioxide. Stimulating the microbes in soil causes them to use up the carbon in soils. This is all published research, literature that's coming out every day. Now, in pretty every developed country that's been doing fertilization for a long time, in North America, for example, almost every groundwater source suffers from nitrogen pollution. When you compare to algae soil amendments, the fact is we don't really know a whole lot about what they do and how they do it. How much goes to the plants? Does a lower percentage go into the feeding of the other organisms? They do not contain nitrogen in a form readily usable by nitrifying and denitrifying bacteria. And they allow significant reductions in groundwater contamination and GHG emissions. So we know they're doing something good, but we've not studied it enough to figure out or quantify what they're doing. The synthetic fertilizers converted to nitrates, soils become acidic, you have to add lime. Okay. Unavailable nitrogen. Soil pH is stable, they modulate soil pH, and there's no need to add limestone because algae contain roughly 144 pounds of calcium ion per ton. So they act as a buffer in the soil. Algae versus manures. We've been using manures for a long time, but while they contain nutrients other than the NPK that you find in synthetic fertilizers, they have slow release of N. There are some disadvantages as well. One of which, for example, they may be contaminated with hormones and antibiotics. So remember what I say, that if it's in your soil, it's going to be likely ending up on your plate. Algae, on the other hand, have all the advantages without the disadvantages. Because they have high nutrient concentrations, it means that you can apply at a much lower application rate. Studies from Korea, for example, are showing that you can put on a ridiculously low concentration of algae and see remarkable results. Okay. Our own research is showing the same thing. Less is more. In terms of greenhouse gas emissions, in their production, the red indicates emissions, the green indicates reductions. And it's only the transport and distribution of algae soil amendments that you have any generation of greenhouse gases. We propose that if you want to grow algae to put on soil, put your plant close to where it needs to be so you reduce this amount. So we can grow in Bangladesh. We can grow in India, Africa, wherever it needs to be. But synthetic fertilizers are chock full of emissions from the production and transportation. I won't go through all of these, but it's just the same litany of benefits of algae versus synthetic fertilizers. And we're just beginning to understand the function. We're just beginning to understand why they're important and how they work. There's a lot more work to be done. So this is a photograph that I was referring to before. One bed not treated, one bed treated. We're getting anecdotal information from actual users of the product. And some of it is really mind-boggling because, for example, we were told that their plants withstood freezes better. And it's going to take some time to figure out why that is, how that is. So we have one author saying that algae offer the only realistic hope of halting and reversing desert encroachment in the Sahel. Recent reports indicate that we're losing arable soil at an alarming rate. One report from 2012 stated that we have less than 60 years of topsoil left. Not good. But these offer a way to bring soil back to their natural health. They play major roles in every biogeochemical cycle on the planet. We spoke about this a bit yesterday. Phosphorus cycle, and dealing with the idea of peak phosphate. So in the presentations by Jennifer and John yesterday on wastewater treatment, that's one of the ways we can close that loop. Because phosphates, when we run out of phosphates, as I said, we're up the creek without a paddle. Nitrogen, silicon, sulfur, oxygen and carbon cycles, the water cycle, they all play a role. So in conclusion, maybe I'm biased, but I think the data will support my conclusions that synthetic chemicals versus algae win every time. They play a critical role in the formation and reformation of soils, pedogenesis and neogenesis. But they are still obscure in terms of our knowledge about what they do and how they do it. You can see the results, but nobody's really spent a whole lot of time to figure it out, to quantify it, to understand and map the pathways. They function in all major planetary biogeochemical cycles. They benefit in physical, chemical, and biological processes. They support the soil ecosystems, the organisms in the soil, and the plants that grow on the soil. But again, much more research is necessary. This is an area, I think, that's been untouched for the most part. We focused on aquatic species, we focused on a lot of other things, but when you talk about impacting global warming and climate change, I think it was Ajit or somebody who was saying that the quantities that you can reduce by just growing algae doesn't make a whole lot of difference. But when you look at it from this perspective, that algae can fix a major carbon sink, then you begin to see how valuable it can be. It's not just about growing algae and having the algae sequester CO2 itself, but their function in soil ecosystems that allow the soil to hold carbon and water. That's how we impact the global cycles. What they help to create, they can help to save. So they're a large part of the soil generation on bare soil. They've done it over hundreds of millions of years. And we can harness them to do the same thing in the future. So, to answer the question, what do algae in soil have to do with carbon capture? They contribute to healthy soils. Healthy soils retain more carbon. Math is simple. Healthy soils, healthy ecosystems, healthy humans. QED. The algae difference. Treated, untreated, cut at the same time. This is the evidence. This is not just the science of understanding it. This is seeing what it does. So in my closing thought, I say in the game of ecosystem Jenga, those of you who know the game Jenga, algae at the base. Remove them, it all falls down. That's how important they are. Not just in soils, but everywhere. But then, I'm a rabid algae evangelist. So thank you very much, folks.